Okay, let's just take a simple 2 by 2 system. 2x plus 5y equals 9 and 4x minus 3y equals 5. Now, presumably we know how to eliminate a variable. For example, we could multiply the first equation by -2 and the second, and then add the second equation. We'd eliminate x. And we just have an equation for y. We'd solve that. We plug y back in and solve for x. Okay. And hopefully everybody's good with that process. Now, if you aren't, you want practice, I've made up several drills posted the 161 site, but I can import them to the Math 61 site if anybody's inclined to do. And one of the drills is just a bunch of equations, a bunch of simultaneous equations. And you work them, answer them, tells you if it's right or not. I think it's set up so there are 8 of them. You try to do them as quick as you can. And you get feedback immediately. So if you want to try that, you can let me know. If you know how to do it, that's fine. Okay, well, I can take this equation and I can write it like this. Okay. I just take these coefficients, the same ones you'd put in an augmented matrix to the left of that dotted line. Stuff that's to the right of the dotted line is going to go here. In other words, numbers on the right hand side of your equal sign. And your x and your y go here. Now the rule. This is a multiplication. You multiply this matrix by the xy. The rule is you multiply rows by columns. So I'm just going to show you how that works without doing it in the matrix. Okay, so the row two 5 multiplied by the column xy equals what? Multiply a row by a column. You multiply the first number in the row by the first number in the column, second number in the row by the second number in the column, or the simple. Okay, so you multiply 2 by x and you get 2x. Then you multiply 5 by y and you get 5y. It's a simple rule. Okay, so do this one for me. See if you can extend the rule a little bit. What if you have this multiplication, 137 multiplied by 2, 4, -1. Okay, now I never wrote this down, so it's not some of you didn't quite pick up on exactly what I said. Here I said you multiply the first one by the first one, you multiply the second one by the second one. So we get 2 times x and 5 times y, and we add them. Okay. Now, if you follow the same pattern over here, and the reason I wrote this down, I wanted to see if you follow the pattern. Some of you got it, some of you are close, some of you need a little more explanation. We multiply first by the first one, second one by the second one, third one by the third one. Did you read that okay? Written kind of small. Then, of course, that's going to be 2 plus 12 minus 7, which equals 14 minus 7. That's going to be 7. The result of this would be 7. Now, once you get the hang of it, it's very simple. But let's get the hang of it, okay? Before we do this. So let's try another one. Let's try 3/8 multiplied by -5, 4. What would that be? Okay, good. You're all picking this up quickly. Okay, we have 3 times -5. Plus 8 times 4, which is -15, plus 32, which is 17. Everybody did the multiplication carefully. Got that. Okay. And if you made a multiplication mistake yet. Okay, how about I'll pull that on you next. Yeah. Well, okay, so what you get is you get, and I think everybody's either got it or, well along the way. You got 4 times 2. I'll use the parentheses here for the multiplications. And probably using formula C. So 4 times 2 plus 7 times 3 plus 2 times -1 plus 6 times 1. That's 8 plus 21 minus 2 plus 6. And we add those up, we get 29, 35 minus 2 is 33. If I add it correctly. Check, you know that. Okay. Okay, so that's simple. Once you see that pattern, there's nothing to it. Okay, so let's try this one. See if you can figure out what to do. Let's say you got 2, -3, 5, 4, multiplied by 3, 5. Okay. So what do you do here? First of all, the result is going to be a matrix, okay? And you've got a row times a column. So we multiply the first row by the column, okay? That's going to give us 2 times 3. And then plus -3 times 5. Everybody's got that. Okay, then we take the second row and multiply it by the column. And we get 5 times 3 plus 4 times 5. And then we do the arithmetic. That's going to be 6 and -15. If I did that correctly, it's -9. And that's 15 and 20, which would be 35. That makes sense? So when we multiply a row by a column, or when we multiply a matrix by a column, it's called a matrix. If we multiply the first row by the column, it goes in the first row of the product matrix. Second row by column goes in the second, but we'll see a little more about what that means. So can you now multiply this matrix of the XY column and rewrite this equation? Okay. Can you do what I did here, but with, well, let's just, yeah, let's just pose that as a separate problem. So something a little uncertain. What would that be? Okay, so no news broadcast. Okay, so what do we do? It's the same thing we did here or here or here, but especially what we did here. We multiply the first row by the column, multiply the second row by the column. First row times a column gives us 2 times x plus 5 times 1. Second row by the column gives us 4 times x and negative 3 times 1. And we put brackets around. Yeah, we've always been brackets, except when we just multiply a single row by a single column. We don't officially need the brackets. It's probably not a bad idea to put them there too. In other words, now, well, that's it. Okay. So, look here. This multiplication is just what we have on the left side here. If I do the multiplication, I end up with 2x plus 5y, 4x minus 3y. That equals 9, 5, okay? Now, if this matrix is going to equal this, then the first number here has to equal the first number. The second number is going to have to equal the second number, right? So this tells us that this has to equal this, and this has to equal this. And of course, that's just the system we started with. Now we're not going to go too much further with this. The next step here that you might or might not see, depending how far you go in mathematics, going into engineering, you're going to have a whole course that starts with this. And we'll stretch it. Okay. It looks like we ought to be able to divide both sides by this matrix and solve for x and y. Okay. In other words, x, y ought to be equal to this divided by this matrix. Catch is, can't divide by matrix. You can multiply by its inverse though, which is analogous to dividing, but not the same thing. Okay. Okay, well, I'm going to show you what you do, and I won't write out the rule. But the hardest rule, if you're not going to do inverse matrices, and we aren't, the hardest rule is the one for multiplication. Addition and subtraction are really easy, so I'm not even going to talk about it yet. Actually, maybe I am going to talk about it. Okay. Let's say we have a matrix 1, 3, 2, 7. I'm going to extend this a little bit. 1, 3, 5, 2, 7, 1. And we want to add this to the matrix negative 3, 2, negative 4, negative 5, 1, 7. Okay. Well, this is easy. This is easy enough once you get the hang of it. This is easier. We just add the 1 and the -3. We add the 3 and the 2. We add the 5 and the -4. We add the 2 and the -5. We add the 7 and the 1. We add the 1 and the 7. Just add them up. Number by number, okay? And it's a good way to say. You just add the first row, first column, to the first row, first column. First row, second column, the first row, second column, and so forth. And of course, then we finish the arithmetic. We get -2, 5, 1, -3, 8, 8. So there's no complication here. So that's easy. Subtraction, you just change all the signs and add them. Change all the signs of the second matrix and add them. Okay. Now, a couple of things you can't do. Well, actually, let's do one more thing. Okay, let's say we have the well, we'll come around here. Okay, one thing you can't do. You can't do that. Why not? Okay, so I think we saw it pretty clearly. If we try to do this, we do 2 times 3, that'd be good. 4 times 2, that's fine. -1 times, nothing there. There's nothing there to multiply -1 by, so we can't do it. Okay. So it's not defined. Okay, what about this? Can we do this? Okay, in this case, we multiply the 2, 4 by the column, okay. 2 times 1, that's okay. 4 times 2, that's okay. But there's nothing to multiply by this 3. If you can't match everything up, it's not defined, okay? This doesn't match up. The only way you can multiply is if everything matches up. In the same way, you can't add 2 matrices unless you have something to match every number up to it. Okay. So you always have to match everything up. Now, when you read your assignment, you'll see that stated more formally. Excited, well, the row and the column both have to have the same length. Okay. It's easy to write down products that don't work. It'd be easy to write out sums that don't work. You know, if I eliminate this last column up here, then I have nothing to match up the 5 and the 1 with. Everything has to match up. Try this one. Did you do this one? Well, go ahead and start. If you find that something doesn't match up, you can stop. Okay. Whenever you're looking pretty uncertain, which is to be expected, kind of looks like they shouldn't match up, but let's just ask, can you multiply the first row by the first column? If you can, go ahead. If you can't, say why you can't. Okay. So, as I said, start by multiplying the first row by the first column. If you do, you get 1 times 1, 3 times -2, 5 times 5. So you're going to add those up. You're going to have 1 and -6 and 25, which I think gives you 20, right? You get 20? You add them up? Anyhow, let's just double check that. You get 25 and -6, 19, and 1 is 20. Now, if you haven't done it, multiply the second row by the first column. Okay, so everybody, I think, has it. Now, 271 multiplied by the 1, -25, second row times first column, that gives you -7. Now, we're going to put it here. Okay, so far this looks like exactly what we have if this was just this matrix times this column. We'll give you this. Okay. So let's color code things just a little bit. First row times first column. I got black chalk and a black board. I could have written that out. Would have been hard to see. Okay, first row, first column, right? Where does the result go? It goes in the first row. In the first column. So green circled row and the blue circled column, I've got surrounded by the green and blue box. Okay. Second row times the first column. I have to break down. Don't want to use yellow because it doesn't contrast. Still have a little bit of purple. Okay. Second row times the first column. Goes here. I don't know if the colors help or not. Might confuse an issue, but point is, first row, first column goes in the first row, first column. That 20 is in the first row, and it's in the first column. The -7 you get from the second row and second column goes in the second row and the second column. Okay. So now let's multiply the first row by the second column, and then the second row by the second column, and see where they go. See if we can position it according to what I just said. Okay, y'all are doing real well with this. You're picking up the pattern nicely. Okay. I think everybody sees it. If we multiply the first row by the second column, we're going to get 27. I think everybody got 27. Everybody agree? Get 27? Okay, let's see. One time, oh, no. First row times the second column. I thought it said 27. That's 1 times 3, which is 3. And 3 times 2, which is 6. So 3 and 6 adds up to 9. And then 5 times 4, which is should be 29. Okay, so if you got 27, recheck your calculation. I think it came on the 1 times 3. Okay, second row times second column is 2 times 3, which is 6. And 7 times 2, which is 14, that makes 20. And that makes 24. Did you get 24? Good, I did one right. Okay. Now again, the second row times the second column, that was our 24. That went in the second row and the second column. Now I'm going to talk a little bit about the way Open Math presents this. We got a bunch of I's and J's and subscripts. And you want to understand those, but I don't think it's a good way to first encounter these with the I's and J's. Until you get the pattern, it makes no sense. Now, maybe it makes sense to you. You know, maybe you're going to like the I's and J's. After you've seen this, it should. Okay. If the first thing you see is all those I's and J's, yeah, I think it leads to massive confusion. Okay. But they're necessary for later. So we're going to talk about it. Okay. Then this row times this column is going to be 5, 21, and 30. That's 56. And here we're going to have 10 and 49 and 6, which is 65. Okay, now that's what I get from the first row and the third column. It goes in the first row and the third column of the product. Okay. Second row times third column, that's going to be 10, 49, 59, 60. I just did that. Okay. Now, first row times the fourth column is going to be 1, 6, 7, and 15, 2, if I get it right. All right. Okay. And then here we get 2, 14, and 16, and 3 is 19. Be right. There it is. Okay. And you don't need the I's and J's once you have that pattern. But I'm going to show you the I's and J's anyway. So get the boards arranged here real quickly. Okay. Now the notation that we use, and the notation is useful for distinguishing rows from columns and so forth, but it can be a little confusing. First see it. Let's do this multiplication. It's simple. Okay, in case you're having a little trouble getting started, let's do the first row times the first column. That's what you do with a matrix. If it doesn't have numbers, you just take whatever's there with whatever symbol and do the operation. And the operation is first row times first column, means this times this plus this times this, right? That's what we've been doing with the numbers. So A11 times B11 is just A11, B11. And then we do A12 times B21. There's our first row times the first column. That's all we can do. Unless we have more information about what some of these symbols mean. Okay. So that's first row times first column. It goes in the first row and first column of this matrix. Okay. Now, let's do the second row times the first column. Yeah, I've done it already. Okay. This is looking pretty good. Everybody's seeing most of the pattern, but let's make sure we see all of the pattern. Okay. The second row times the first column. A21 multiplies B11. And A22 multiplies B2. Now, why did I put it here? It's because you really want to make sure you see that. Okay. This is the second row in the first column, right? This is in the second row in the first column. Okay. So what you get when you multiply the second row by the first column goes in the second row, first column. There's a second column because you got to multiply these two, right? So we do the first row times the second column. Where's that going to go? It's going to go in the first row in a second column. Okay. It always goes in the corresponding row and column. Okay, so we do A11 times B12, second row times the second, first row times the second column, and A12 times B22. Then we multiply the second row by the second column, and the result goes in the second row and the second column. So it's going to be A21, B12, plus A22, B22. Now, take a look at the subscripts here. Do you see a pattern in these subscripts? I just showed you this without seeing where it came from. Can you recognize a pattern on it? The way the subscripts are matched up. Okay, we got a good start. We're seeing, yes, I might end up with it. And we don't call it 11, it's 1, 1. Okay, because it's the number of the row and the number of the column. It's two different numbers. So, but the B11 is common here. The B21 is common here. The B12 is common here, and the B22 is common here, right? Okay. So you can see that all the way across. And there are other patterns you can see now. The one I'm going to take a note of here. We're not going to do too much with this. I just want you to get the idea of looking at the subscript and understanding. Okay. What's the significance of 1, 1 for this number? This number. Well, it's the first row and first column, right? Okay. What's the significance of the 2 and the 1? It's the second row, first column, right? If I do these in order, or I do this one first, then this one, then this one, right? I get 1, 2 here. This is first row, second column. And this is second row, second column. Okay. So, now there's other patterns. We'll just kind of leave it at that. And you'll see other patterns when you read the text. The reason for this notation, though, is that it does make sense of the order we do things. Okay. And it can be expanded to any number of dimensions. And I think your material actually gets into some stuff with summation notation. And I'm not going to talk about that today. I can talk about that next week if that becomes an issue. That's where it kind of gets a little bit messy, a little bit hard to look at, unless you're ready to just wire that. Okay. Let's see the patterns. And that's as far as we're going to go with seeing the patterns. Okay. Okay. Well, there I am in the text. How do I get back to the? I don't see any. Maybe just having a senile moment here. I don't have any back arrows. Oh, I get it. 2 different windows. This thing drives me nuts. I got to scroll down. I've got no way to scroll down. Nothing over here, nothing over here. The only way I'm going to be able to scroll down is to put my mouse, connect my mouse. So give me a second. I love this laptop, but that's one part of it that I don't love so much. And actually the software should be behaving a little better, but you know, I think the open mass software works pretty well for most things. There. I just want to quickly preview. Yeah, another important thing is there I was complaining about my computer and I still have the recording on. Okay. There's a little bit of space that I apologize for that. I've modified these matrices this time this, okay? Can I modify them the other way? Can I do this? Is that possible? Or is that not possible? I don't know what I'm doing with this computer. I think I just turned it off and then started talking, but yeah, just wait out. I think I turned it off and didn't turn it back on when I was playing it. But we're looking, if we do this, try to do this backwards. Then we have this matrix on the left, this one on the right. And the rule is we've always got to multiply the rows on the left by the columns on the right. And we can't do that because the columns on the right have different lengths than the rows on the left. If we try to multiply this, we try to do 1 times 1, that's fine. We do 3 times 2, that's fine. We do 5 times, nothing multiplied by. So the statement I made, this is impossible. The rows in the first matrix don't match up with the columns in the second. They have different lengths. Okay. Let's take a quick look. If I want to do 5 times the matrix 1, 3, 5, 2, 7, 1. What do you think I'd do? Well, we're out of time, so I'm not going to break it out of you. Give you a chance to answer, but we just multiply 5 by every number, like the distributive law. So that's a real easy rule to get used to. And again, all the rules are pretty obvious, except the one for multiplication, which is what we spent most of our time on. Okay. So there we have it.